Well, this project is a bit of a rework of something I did earlier, but I'm doing it again because I think I've got better at the bronze casting process, and I've also bought one of those action cams so I can get some nicer shots. Now, like all my other videos, the process is to design the part in Fusion 360, 3D print it, then to get rid of all the printing lines and artifacts, spray it with car body high build primer and sand it, set it into a sand mould, and then take it outside for the pour. Now, I'm making this cast with LG2 gunmetal bronze, and its pouring temperature, it needs to be, I forget now, but it was around about 1200 degrees, and that really is on the absolute limit of what I can manage with my setup. You get the feeling there's maybe 60 or 70 kilowatts of power going in, and at those sort of temperatures there's 69.9 kilowatts coming straight back out the sides. So maybe I need to think about a better furnace design. But anyway, I can just about get there. And now I'm up to temperature, I'll take the lid off and I can get the thermocouple out. So the thermocouple is a K-type which I found off eBay. Unsurprisingly, they don't last very long under this sort of stress, but it's fairly easy to fix with a TIG welder and some stainless steel tube. You just strip it all back, you can bond the ends back together and then close the tube again with the TIG. Anyway, I'll skim off the dross. It's also worth saying that I've got some borax flux in there. And now I'm ready to lift the crucible out with the lifting tongs and put it into the pouring hoop ready for the pour. There's coming up about 2 kilos of bronze in that crucible, and once you're lifting it with the pouring hoop, it's actually pretty heavy. But you can see as I pour, it starts to set as it's coming out of the crucible, and it looks a bit gummy. I think this means that I haven't quite got it up to temperature, and it's just not hot enough. That being said, it does seem to work, but I do find after the pour, it helps if I just bang the side of the mould with the pouring tongs, just to try and knock everything and make sure everything flows. Once it's cooled down a little bit, I can separate the mould and get the cast out. Now, where I think I could do better is to find some way of clamping the two halves of the mould together, because what you can see here is I do end up with a bit of mould flashing that I've then got to deal with by hand. Looking at the video now, I wish I made a better job of cleaning up the casting before I filmed this, because all the soot left over from the sand is making the surface look a lot rougher than it actually is, so you'll just have to take my word for that one. The next job is to separate the wheel from the sprue, and then I'm going to take it over to the milling machine just to tidy up the face a little bit with a view to avoiding any interrupted cuts on the lathe, and I'm also going to use an edge finder just so I can centre drill the middle of the wheel and then use that to align it in the lathe later on. To start with, I've just aligned the part in the four-jaw chuck by eye, which is fine for the outside face, but for skimming the diameter I need to do a little bit better. Next I've got a ground silver steel bar, which I've turned to a taper at one end, centre drilled at the other. I can then hold it between the wheel and a live centre, and use a DTI to align the four-jaw chuck, which I've not shown here. That's enabled me to get a good accurate hole through the middle of the wheel, and then of course it's a fairly easy job just to skim the outside diameter and finish things off. Well, this was just a quick video whilst I'm in between projects, but hope you got something out of it, and please do leave a comment, good or bad, let me know what you thought.